Welcome. Today I'm going to give you a Swift introduction to the programming language Swift. Specifically, I'm going to try to answer the question, what makes Swift Swift? Like, what about this language is so interesting and cool that I want to get up here and talk to you about it? And I'm going to answer that question by showing you some examples of my favorite features in Swift and how I've used them while writing the MongoDB Swift driver. So you're also going to learn a bit about how a driver works today. Speaking of drivers, my name is Kaitlin Mahar. I'm an engineer on the drivers team at Mongo, and I mainly work on the Swift driver. And I'm going to start off by giving you a bit of context on drivers and the Swift driver in particular so that my examples going forward are more meaningful to you. So what is a MongoDB driver? The drivers team writes software that allows people using all different programming languages to connect to MongoDB. Basically, applications talk to the driver for their programming language, and then the driver talks to MongoDB. And the application and the driver communicate in the form of documents, and the driver and MongoDB communicate in the form of BSON, or binary JSON. So we have a bunch of drivers you might be familiar with if you've already used MongoDB, like PyMongo for Python, the Node driver, the Java driver, and all these provide really idiomatic interfaces in their languages to MongoDB. And now we recently wrote this new driver for Swift. And you might ask, why? Well, the really short answer is to allow people writing applications in Swift to connect to MongoDB. But the more compelling answer, which you probably figured out if you went to the keynote this morning, was for MongoDB Mobile. If you want to know all the details of how mobile works and where the Swift driver fits in, you should go to the MongoDB Mobile session right after this in, I think, the Gibson room. But at a high level, basically, the Swift driver is part of that whole stack and allows you to use Mongo Mobile on iOS. So with that context in mind, let's move on to talking about Swift. So what is Swift anyway? I didn't really know the answer to this myself like 6 months ago, but I'll tell you what I've learned so far. So Swift is a programming language that was developed by Apple, and it runs on all of your Mac devices, and also mostly works on Linux. It was first released in 2014 by Apple. It's a proprietary language, but they decided to make it open source in 2015. And as of now, the latest stable version of Swift is 4.1.2. So there have already been 4 major version releases. You might ask, why did Apple decide to create this language? So for a bit of background, before Swift, the language that Apple would use for everything was Objective-C, which is basically a thin layer on top of C, giving it object-oriented capability. So Objective-C was clearly really powerful. Like, it got Apple all the way up to 2014. But they wanted to create something more modern that sort of addresses a lot of the shortcomings Objective-C has. So when they released it, they called it Objective-C without the C. And it provides a lot of the same features as Objective-C, but it's a lot safer. Like, you don't have to work with memory by default and that sort of thing. And its Swift syntax also sort of addresses a lot of weirdness in Objective-C syntax. Like, here's how you concatenate 2 strings in Objective-C. And here's how you do it in Swift. So to me, one of those looks a lot easier to learn and pick up on. So if Swift is like so much easier to use, then why are people still using Objective-C? For one thing, Swift is still a really young language. Like, in the scheme of programming languages, 4 years is not really anything. So people haven't really had time to adapt. Building off of that, the community of people using Swift is still pretty small. So as a developer, this can be frustrating when you can't find people who are working on similar things to you, or you can't find resources. And also, as I mentioned, there have been 4 major version releases of Swift, and each one has come with a lot of breaking changes. Like Swift 3 code won't compile in Swift 4, and so on. And this means a lot of resources become out of date quickly, and it also makes people wary of committing to Swift because they feel like they're going to have to rewrite their application in a year or 2 anyway. So with those caveats in mind, you might be like, well, why would I start using Swift now? I think the answer is that Swift is really powerful and has a lot of really great features. Despite its immaturity, the developers are really working on prioritizing like the issues that people have brought up with Swift. And it already has such a great feature set that I'm going to tell you about next that I think it's worth trying out. So specifically, for the rest of the talk, I'm going to focus on my favorite features of Swift, which are how easy it is to work with C libraries and its really powerful type system. So Swift makes working with C libraries really easy. And to you, that might seem like kind of a random thing for me to be excited about, but it was really important for the Swift driver because the Swift driver wraps the C driver. So I'm going to talk about this first because it's sort of the backbone of the driver and the rest of my talk. So as I mentioned, the Swift driver wraps the C driver. And we implemented it like this for a couple of reasons. For one, Mongo Mobile knows how to talk to the C driver. Again, go to the talk after this for more details. But for another reason, wrapping a driver means we get like a correct, good driver really quickly without having to do everything from scratch. So basically, the Swift driver imports the C driver. And then every time you call a MongoDB API function in the Swift driver, like insert one, we call the corresponding function in the C driver. And then the C driver actually does the talking to MongoDB for us. But to the user, from their application, it feels like they're just using a Swift library. And implementing this code-wise actually wasn't that bad. And the reason for that, or one reason for that, is that Swift provides really descriptive C pointer types. So this is possibly a non-exhaustive list of all of them, but as you'll see, they all have really descriptive names that indicate to you like what you can and cannot do with them. For example, a pointer can be opaque or not, and if it's opaque, that means we can't access the internals of the type. In contrast, the other ones are called unsafe, not really the opposite, but those are the non-opaque ones. And so pointers can map to particular types, which would be indicated in their name, or they can be raw, meaning they go to untyped memory. They can be mutable or not, meaning that you can write to them. And they can be buffer style or not, which means you can iterate through them. So as a developer, all of this is really nice because you know right away by looking at the type name what you're going to be able to do with it and what you won't be able to do with it. And this is really great as we use these pointers all throughout the driver. So for example, in sort of our main three MongoDB classes for a client, database, and collection, all of these wrap an opaque pointer because the C driver doesn't give us access to the internals of those types. But we're able to pass it back and forth to store it in our classes and that kind of thing. In contrast, we also use some unsafe pointers in the driver. So we have this document storage class that basically wraps the C driver version of a document. And it stores a pointer to that, a bsont. And this pointer is mutable because we're allowed to write to it. We can add new keys and values to the document. So yeah, as I was saying, like from the perspective of someone actually using this, it's really nice that I can see that pointer and be like, oh, I'm going to be able to modify that or not. Despite all these, there are still some challenges of working with Swift and C. For one, as I mentioned, the community of people using Swift is pretty small. Community of people using C and Swift is even smaller. So that can lead to some difficulty if you run into like weird issues. And also, despite the help you get from Swift, you do still need to think about manually managing memory and that kind of thing in a way that you're probably not used to doing when you write code in a high-level language. So that can lead you to some subtle bugs. But overall, Swift provides a lot of great features for working with C, and at least for me, it's way better than using a C library actually in C. And that's mainly because you get to take advantage of other really cool features of Swift, like its powerful type system, which I'm going to tell you about now. And I'm going to focus on 4 components of this type system specifically: Swift support for optionals, extensions, protocols, and generics. So Swift has built-in support for optionals. What is an optional? Well, normally, say I had an integer called myInt. That means that this variable is allowed to take on any of the legal integer values. But what if I want my variable to be able to not have a value at all? That's where optionals come in. So it's basically a value that's optionally set. I indicate that in Swift by putting a question mark after the type name. And that basically means that my variable can take on any of the allowed values for an integer, or it can also be nil. So these are really useful to us in a lot of places in the driver because the MongoDB CRUD API is sort of full of these options that a user can provide, but they don't have to. So for example, for one of these, when you retrieve a collection from a database, one thing you're allowed to provide is a read concern, which it doesn't really matter what that is, but it's an option you can set on the collection. And then when you create this, or when you retrieve this collection from the database, you can optionally provide that read concern. And then the method to get the collection looks something like this. And you'll notice that the options that this function takes in are also optional. And Swift provides us this really nice syntax, as you'll see down here, that allows me to say, if the options were provided and they have a read concern property that I set to this variable, then do something with it. But if they aren't set, then I don't have to do anything. But I have this really nice, succinct way of expressing that in the driver. Another really powerful Swift feature that kind of is the basis of some other of my favorite features in Swift is called an extension. And this is a pretty simple concept, but it's really powerful. So an extension allows you to add new functionality to an existing type, like a type built into Swift or from someone else's library. So one place we did this in the driver was extending Swift's built-in date type, which we're able to do by just saying extension date. So we added two things to date. One of these is an initializer that takes in a 64-bit integer. And one of these is a property, which is sort of the reverse of that, converting the date back to that integer. And this is really useful to us because the way that dates are stored in BSON, this object we use for, or the format we use for serializing data, dates are stored as these 64-bit integers. So having this stuff built into the date type is really nice. We don't need like a helper function or anything to do this kind of conversion when we're encoding and decoding. And extensions sort of set the basis for another really cool sort of integral part of Swift called a protocol. You'll hear Apple talk a lot about protocol-oriented programming when they're talking about Swift, but what are protocols? So it's basically like an interface in another language, and it specifies a set of properties, methods that a type needs to implement if it wants to conform to the protocol. And Swift has a bunch of built-in protocols, and you can also make your own. And classes, structs, and enums are all able to conform. So one really cool built-in protocol is called expressible by dictionary literal, which is pretty much what it sounds like. It means that you can initialize your type using a dictionary literal, so this kind of syntax. And to implement this protocol, here's what's required of your type. Basically, you need to declare these two associated types, indicating what type your keys are and what type your values are. And you also need an initializer that takes in an array of those key value pairs. So you might be able to guess what type we wanted to make expressible by dictionary literal in the driver. It's a document. So all that required of us was writing this pretty simple initializer that takes in that array of values, which we then iterate through and set on the document. And you'll notice I didn't even have to actually specify those associated types. The compiler infers them for me based on what I used in the initializer here. So that's really nice. And then that allows our users to write their documents like this in a format pretty similar to like the Mongo shell or anything like that. And there aren't just built-in protocols. You can also make your own. One place we did this was when we were designing the BSON library. So there's a bunch of different types that BSON values can have. And some of these map really naturally to existing types in Swift, like a double or a string. But some of them, like object ID or document, required us to write our own custom type. But we wanted to be able to group all these types together in some way. And a protocol allowed us to do that. So we wrote this protocol called BSON value. And basically it says that any type that wants to be a BSON value needs to know its own BSON type. That's basically just an integer from the BSON spec, indicating whether it's like a string or a double or something. It needs to know how to write itself to a document in the C driver. And it needs to know how to create itself from an iterator over a document in the C driver. And we're able to make our custom types conform to this, basically by just creating the type, adding this to the definition, and then adding those methods on it. And we also are able to extend built-in types to conform to the protocol. And so this is really powerful because it gives us this grouping of our own types and these built-in types together. And something nice about protocols is that you can use them as types. You might have already noticed me doing that, but I can say that like a function returns a BSON value, and then that will allow me to return a value of any type that is a BSON value. And the final thing that I think sort of completes Swift's type story on top of protocols is generics, which you may also be familiar with from other languages. But they basically solve the following problem. Say I wanted to have a stack of integers. That struct would probably look something like this. I have an array backing it, and it supports pushing and popping values. Okay, but now what if I want a stack of strings? That would look something like this. Basically, it's the same exact code, but I replaced every place it said int with string. And so it's kind of silly for me to have to duplicate this code. So generics help me to solve that problem. So in Swift, you could write a generic stack that looks something like this. Basically, it has something called a type parameter, this element thing, which I get to name whatever I want. And then any place I would have used int or string before, I just use element as this placeholder now. And then this kind of stack will support literally any kind of item with just these few lines of code, which is really nice. And I'm also allowed to place constraints on this placeholder type. For example, maybe I want to be able to sum all the values in my stack at any given time. So I might make a number stack, and I could place a constraint on the element to say that it's numeric. Numeric is another one of those built-in Swift protocols that all the numbers implement. And if you're numeric, that means that your values can be added together using the plus operator. So we use generics in a lot of places, but I think probably my favorite one is with Swift collections. Or with Mongo collections. So we have an associated type with collections, and that type needs to be both encodable and decodable, which means that it knows how to convert itself to BSON and from BSON. And by having this associated type with a collection that we just know is encodable or decodable, we're able to support users inserting like their own custom Swift types into collections and looking them up from collections really naturally, which is really powerful because it doesn't require you to work with documents. You can work with your own types. Of course, there are still some challenges of working with Swift's type system. My biggest complaint at first, well, most of my complaints stem from the fact that it's still really new. Like there's some things that seem like they should exist, but don't. For example, when I first started using Swift, there's no way to get an auto-generated equality method or hash method. You had to write them all manually, which could be really annoying if you had a struct with like 20 properties or something. However, this was added in Swift 4.1. Both of these were added in 4.1. Another thing I wanted was conditional protocol conformance, to say my type only conforms to the protocol when something else about my type is true. Specifically, I want to be able to say like an array only conforms if every element meets this thing. So they did add this in 4.1, but you can't dynamically check at runtime if something actually conforms, so it sort of defeated the purpose for me. I think in 4.2 we might get the full thing. And also like some other things, like I mentioned that we have that type associated with a Mongo collection. I wanted to be able to make that type by default a document, but you can't. But I have seen people propose this for Swift, so maybe we'll get it someday. So even though Swift sort of has these growing pains, it's always really encouraging to me that like any idea I think of for Swift or any feature I want is like coming soon, in progress, or has at least been proposed by the people developing Swift. So just to summarize all of this about Swift, here's what I want you to take away. Swift is really new and exciting. It has a lot of promise, and people are thinking about using it not just for iOS anymore, and using it for other applications as well. Swift's type system is really powerful. It has all these cool features I talked about, and also other ones that I couldn't fit in here. Swift makes working with C libraries really easy if you need to do that. And lastly, you should try writing it, because you might like it. And what's next for the driver? We're working on taking the driver to a 1.0 release. Currently, it's in a beta state. And this will include things like support for the full CRUD API, the new 4.0 features you've been hearing about today, more complex configurations of MongoDB, like replica sets, and that kind of thing. We're also exploring integrating with all these Swift web frameworks I've mentioned that are popping up, because those would be a really natural place for people to use the driver. And finally, we're considering replacing some of the places where we use the C driver for BSON with native Swift code. So if you want to learn more, as I mentioned, there's this MongoDB mobile session right after this. I will also be there. And you can hear about all the components of mobile and how they fit together. And here are some resources I recommend if you want to get started learning Swift on your own. So that's it. Let me know if you have any questions. Yeah.
Like, do you see people writing like applications like I would normally write a job application, only I'd write it in Swift? Or is the magic that's in the next thing where mobile apps could be connecting directly to Mongo?
So there are a lot of people who are looking into more like server-side Swift. There's all these web frameworks that have come up at like IBM and places like that. I don't know if people are using it maybe in places they would have used Java before, but maybe in places that they would have used like JavaScript. People might be using Swift for web apps now. But yeah, you should come to the mobile session after this.
So the Swift driver, it wraps C driver, right? What sort of an overhead does it add to be wrapping another driver?
So, sorry, what sort of what?
Like, does it add an overhead since you're wrapping another driver?
It does add some overhead. The Swift driver is still on par with some of the other drivers that are like not wrapping C, but yeah, there is fairly significant overhead compared to just using C.